Okay, look at question number 17. The rate of change of water temperature is described by the differential equation. The rate of change of water temperature can be increased or decreased. Okay. Here they say theta is the water temperature at the time t. Okay. Theta is the temperature of the water. So if you look at here, this one, theta is the temperature of water. Okay. Here at time t, or here the graph also can. If you look at the graph, theta, this is theta, and then this is time t. Okay, like this. Let's say theta is here, because I'm not going to draw this because too many lines are like that. Theta is the temperature at time t, and then theta s is the surrounding temperature, and K is the positive constant. Okay, the boiling water at a temperature of 100 degrees Celsius is left to cool in a kitchen with the surrounding temperature of 25 degrees Celsius. If the water takes 1 hour to cool down to 75 degrees Celsius, show that K equal to this. So what is given here, you can show it in the graph like that, just a sketch. You see, the boiling water at a temperature of 100 degrees Celsius, that means starting from 100, is left to cool. That means the temperature will drop. It's a curve, exponential. That's why E is very important. To cool in a kitchen with a surrounding temperature of 25 degrees Celsius, and the water take 1 hour. 1 hour to cool to 75. Okay, so this point is the y-intercept. This is for us to find C. This is for us to find K. That's why they ask us to show K equal to ln 3/2. So, like this. We just put down our, what we call the surrounding temperature, and then we integrate the just now separable variable, and then you can integrate, you get this. Okay, after that, you just substitute the initial condition, theta t0, theta 100, and then t equal to 1, theta equal to 75. So you substitute here, you get the C is equal to this, and then with the C you bring it over here, you substitute again to find the K, you get this is the K. Okay, this one you can go through. Okay, so this is the general solution. Okay, then after we get everything, we substitute inside, then we get the particular solution after we substitute the C and everything here. Okay, now we read the second part. When the water temperature reaches 50 degrees Celsius, it is then put in a freezer with surrounding temperature. That means now the surrounding temperature changes. Okay, the surrounding temperature before that is 25, now become -10. To form ice, find the time needed from the moment the water is put into the freezer until it forms ice at the temperature of 0 degrees Celsius. So when you put inside the freezer, the surrounding temperature will be different. So we have to consider another case now. Now here, this is the temperature of the water, and then the surrounding temperature in the freezer is -10. So, and then when do you put in the freezer? When the water temperature reaches 50 degrees Celsius. So from here, if you look at the graph here, now when the temperature is 50, then it's still, because we put in the freezer, it will cool down until, it will go until -10. Okay, it will go until -10. But you want the time when it become ice. Okay, 0 degrees Celsius. So what is the time needed here? What is the time here? Okay, you want to find the what we call, there you see, find the time needed from the moment the water is put in the freezer until it forms ice at the temperature of 0 degrees Celsius. So you want to find the time here. You want to find what is the time here to form when it become ice. Okay, so now we come back to our equation just now. This is our equation given. Newton's law of cooling. d theta over dt. Now our surrounding temperature is negative 10. So we just substitute. Okay. But here you see the K is still the same. K no change. Why? Because this is, we still use the same water. We still use water. Okay, we don't change the liquid because you see, note K is still this one because same liquid, that is water. If different liquid, then the K will be different. Okay, but this is the same. Okay, so the K will remain the same. So d theta over dt, this is our K just now, and then theta minus negative 10, so you get this, then you differentiate, separable variable, you integrate. After that, you substitute. Okay, from the graph just now, this one is for us to find the C. So we need to find C only, no need to find K. That's why they don't give you another case. They just give you the initial condition. They don't give you another condition because K don't need to find already. K we use back the previous one because same water. Okay, so theta equal to 0. T equal to 0, theta equal to 50. So substitute. So when you substitute t equal to 0, theta equal to 50, you get C equal to this. So this is a general solution. We substitute the C inside, become a particular solution. That means it's particularly correct for this situation. Okay, then and then we want to find the time when it become ice. So when it become ice, theta is 0. So you substitute theta equal to 0, then you find what is the t. So you find what is the t, use a calculator, you get t is 4.42 hours, or 4 hours and 25 minutes. Okay, so that's how we do. Okay, you can try until question number 18.